Now that we've seen the different types of data and levels of measurement we can have, we are ready to explore different graphs and tables, which will allow us to visually represent the data we are working with. Visualizing data is the most intuitive way to interpret it, so it's an invaluable skill. It is much easier to visualize data if you know its type and measurement level. As you may recall, there are two types of variables, categorical and numerical. In this video, we will focus on categorical variables. Some of the most common ways to visualize them are frequency distribution tables, bar charts, pie charts, and Pareto diagrams. First, let's see what a frequency distribution table looks like. It has two columns, the category itself and the corresponding frequency. Imagine you own a car shop and you sell only German cars. The table below shows the categories of cars: Audi, BMW, and Mercedes, and their frequency, or in plain English, the number of units sold. By organizing your data in this way, you can compare the different brands and see that Audi has been sold the most. So, that is a frequency distribution table. However, tables aren't much fun, are they? Using the same table, we can construct a bar chart, also known as column chart. The vertical axis shows the number of units sold, while each bar represents a different category indicated on the horizontal axis. In this way, it is much clearer that Audi is the best-selling brand. Okay, let's represent the same data as a pie chart. In order to build one, we need to calculate what percentage of the total each brand represents. In statistics, this is known as relative frequency. Naturally, all relative frequencies add up to 100%. Pie charts are especially useful when we want to not only compare items among each other, but also see their share of the total. Okay, this example could be easily transformed into a business example of market share. Market share is so predominantly represented by pie charts that if you search for market share in Google Images, you would only get pie charts. Imagine that the data in our table is representing the sales of Audi, BMW, and Mercedes in a single German city, say Bonn. The chart will show us the market share that each of these brands has. Lastly, we have the Pareto diagram. In fact, a Pareto diagram is nothing more than a special type of bar chart, where categories are shown in descending order of frequency. By frequency, statisticians mean the number of occurrences of each item. As we said earlier, in our example, that's exactly the number of units sold. Let's go back to our frequency distribution table and order the brands by frequency. Now, we can create the bar chart based on the reordered table, and voila! We almost have a Pareto diagram. There is one last touch to make it one, a curve on the same graph, showing the cumulative frequency. The cumulative frequency is the sum of the relative frequencies. It starts as the frequency of the first brand, and then we add the second, the third, and so on, until it finishes at 100%. This polygonal line is measured by a different vertical axis on the right of the graph. At each of its vertices, it shows the subtotal of the categories to its left. See how the Pareto diagram combines the strong sides of the bar and the pie chart? It is easy to compare the data both between categories and as a part of the total. Furthermore, if this was a market share graph, you could easily see the market share of the top 2 or top 5 companies. Finally, it is named after Vilfredo Pareto. You may have heard of another idea of his, the Pareto principle, also known as the 80-20 rule. It states that 80% of the effects come from 20% of the causes. A real-life example is a statement by Microsoft that by fixing 20% of its software bugs, they managed to solve 80% of the problems customers experienced. A Pareto diagram can reveal information like that. It is designed to show how subtotals change with each additional category and provide us with a better understanding of our data. Okay, these are the main ways in which we can visually represent categorical data. In our next lecture, we will get acquainted with the most useful graphs and tables for numerical data. Thanks for watching.